Welcome everyone to this episode of Green Talks. We're back to talk about research on renewable feedstock and waste streams in the chemical industry. I'm Thomas Setche, your beloved host once again from Green Hub Twente. Today we can welcome the long-awaited Dr. Pilar Ruiz, who will talk about her research related to SDG 9 on industry innovation and infrastructure and SDG 17, partnerships for goals. Thank you, Pilar, for accepting our invitation.
Thank you very much for inviting me. It's really a pleasure.
Could you tell us about your academic and research background, please?
Yeah, so I'm originally from Spain. I studied there at the University of Zaragoza a long time ago, chemical engineering. And then I did also my PhD there, my PhD studies. I went for a postdoc later to US. And after that, I worked almost 6 years at a company of renewable energies with the headquarters located in Spain. And after that, I came here to the University of Twente to work at the Sustainable Process Technology Group, where I do research on developing chemical processes, sustainable chemical processes that uses alternative feedstocks, more sustainable feedstocks like lignocellulosic biomass and plastic waste.
Exciting, and we're going to hear more about that in this episode. So, before you explain all the details to us, how we can make alternative fuels and why it's so cool, let me ask you this first. What is your most unsustainable guilty pleasure?
Okay, if I think on a pleasure, I can think of on holidays. Mm-hmm. And I would say normally in summer I go to Spain also for holidays and I go driving. Mm-hmm. I'm not sure if that is the most sustainable way, but it's the most convenient one for me. So,
definitely the train infrastructure still could be improved. All right, so I wanna hear about what motivated you to get into alternative fuels and waste recycling and start somewhere which we all know is super unsustainable.
Yes, the motivation part and the starting point, if you think on the oil and chemical industry, it delivers the products that are in our daily life everywhere, but not only the fuels that we use for our cars, right? But you can think of our clothes, on our any material, on construction, on packaging, on our computers, laptops, phones. So it's everywhere. So there is a huge demand for these products, and of course also imagine fertilizers, right, to grow the food worldwide. So there is a huge demand, and it's clear that we need to move to a more sustainable way to deliver these products and reduce the carbon footprint.
Okay, that's pretty much understandable. So we need to make it sustainable ASAP, of course.
Yes.
What role does sustainability has in your life right now?
Yeah, in my life in general, is everywhere. Of course, from the point of view of research, as I mentioned, I develop a sustainable process, right? So that's the core of my research, trying to work with these alternative feedstocks, and also of course in teaching also. As a teacher here at the university, the sustainability plays also an important role. I teach courses on sustainable chemicals, sustainable fuels, also in the chemical and science engineering program, but also in the Master of Sustainable Energy Technology.
Great, big shout out for that.
Yes.
Thank you.
Thanks.
Now let's go into our main topic today, alternative fuels and waste. Let's start with what they are and how are they made, where we are in developing them.
Yes, so in this specific case, for example, when I work with more sustainable feedstocks, I'm talking about using lignocellulosic biomass, for example, and also other waste streams. In the case of lignocellulosic biomass, of course, we try to use these more sustainable feedstocks, and in this case, we made already a change, right? We don't want to compete with food industry, so that's why we made already a movement years ago. But this is the way society is moving, like to use more sustainable feedstocks. In the case of the biomass, these studies started long time ago. In my case, it's already 20 years working on this type of development of processes, right? That deal with this complex feedstock also.
And in academic terms, where would you put us now? In what phase of developing biofuels are we now?
Yeah, so we are at many different stages, right? As I mentioned, with the biomass, we have been studying them for a long time. So there are different stages of development there. So, of course, also industries have implemented a few of these technologies, right? There is also a strong commitment towards the sustainable aviation fuels. For example, we already have seen few flights already running and testing these biofuels. So, and also looking also for alternatives that we can produce from the same biomass. So there are processes that are still more mid-term, long-term, but there are some that they are already in place.
I believe that for the ones that are not that specialized in chemical engineering, it could be very interesting to hear how they are produced actually. How do you produce such biofuels?
Biofuels, yeah. So, for example, if we think on the biomass, right? Perhaps people are more familiar with the ethanol production. So we think in the past we used to do first generation ethanol, right? We have the cereal, sugarcane, which is rich in sugars, and then we ferment them eventually to produce ethanol. Of course, at some point it was decided, okay, this is not so sustainable because we are competing with food, so then we should move to alternative feedstocks. And then that is the case. Then we move, instead of the sugarcane or the cereal, we use the leaves or the stems that are connected to that, like the waste that we generate from these streams. In this case, there is a more complex structure because we don't have only the sugars, but we have the sugars but another components like lignin. So then this structure becomes more and more complex, and you have less sugar available also to produce the same fuel.
Okay, so can we conclude what are the advantages and disadvantages of using biofuels in that case?
Yeah, so for example, advantage is clear, right? We reduce the carbon footprint, we are using waste, so that is a huge advantage. Disadvantage, I would call it challenge, right? Because we are dealing with a more complex feedstock. So then we need to do some certain pretreatments that you don't need to do in the other cases. That could be energy consuming steps, high energy consumption steps, or could be also that we need other chemical solvents in order to release the fractions we desire. But also considering this challenge, when we have challenges, right, we have also opportunities, right?
Correct.
And this is
solutions.
This is the way we try to tackle the case of the biomass. The biomass is such a complex structure that can deliver us not only fuels but also many chemicals, many materials. And then the roadmap of products that can come from biomass is really extensive. And then we try to develop these integrated biorefineries where we can produce and take advantage of the whole structure of the feedstock.
Okay, so you were talking about the ethanol. How could we use ethanol as an example to decarbonize our industry?
Yeah, now ethanol, it's a known example that you can see in the gas stations, right? When you go and tank your car, you can see that there are still already mixtures of gasoline with ethanol. So that is one case that is already in place. But as I mentioned, the sustainable aviation fuels is another example going on.
Yeah, and I, as far as I know, actually the Dutch are pretty forward, and they have a lot of development when it comes to sustainable aviation fuel.
Yeah, indeed. Yeah, there is a strong commitment, but not only from the Netherlands in general, from the European Union also supporting and subsidies for sustainable aviation fuels, but also maritime fuels, and also in general worldwide also. Yeah,
great. We're going to talk about this in a minute. But before that, so you mentioned challenges as being energy intense and the challenges to improve yields as well and to optimize all this. How do you tackle these challenges right now? What do you try to change? What variables can you change to tackle these challenges?
Yeah, so as any chemical process that you can think of course, the challenge is always to provide and optimize the yields that we want to obtain regarding the desired product, and also how to integrate all this energy consumption in the system. Or sometimes also in some of the steps we generate energy. How can we integrate that? So how I tackle them, so I'm an experimentalist, so most of the time I study the problem, right? I test what's going on, the type of reaction is happening, the problem we have. If we have a byproduct that it can be used somehow in another part of the process, if we can integrate energy steps in the process, and also how can we separate the different streams.
So that sounds a lot like you're also trying to use some kind of circularity within your processes to reduce waste. So where does that come in? I mean, I understand maybe the importance when it comes to your research, but you also focused a lot on plastic waste recycling. And why is that?
Yes. So as I mentioned, for example, in the case of biomass, it can deliver in our process many different products. So the best approach is to try to use these byproducts also within our product, within our process. Imagine, for example, one solvent that we can reuse internally, right? But of course, if we think worldwide also, we have the problem of the plastic waste, right? The plastic waste that is coming to the earth, to the seas. So this is something we need to tackle and process better.
Yep.
So plastic waste is another of the lines that I research on, and this is very important. I develop a process for chemical recycling of plastics. So the first step would be, of course, as much as we can reuse, but then in a moment that we have all the plastic mix, mechanical recycling should be there, right? We should separate and get value of the major streams we can. But it's a moment that mechanical recycling may limit because we lose properties of the materials, or because we have such a complex mixture of waste that we cannot separate further. So in these cases, when chemical recycling plays an important role, and it will play an important role in this circular economy using the plastic waste, and the idea is from plastic waste, process it back to a liquid or a component, a product that can be fed in a naphtha cracker, for example, and then we produce again the monomers and back the polymers, and then we close the loop of the plastics.
Okay, so chemical recycling is basically trying to break down the final product that have to be recycled, and then you feed it back to the system.
Yes, and you create more new plastic.
Yeah, but in a way, like you said, obviously the advantage is that it's more clear, so you don't lose material property. But isn't it more expensive than mechanical recycling, for example?
Yeah, I mean, you need the energy, right? You need the temperature or the energy in order to depolymerize the plastic. But also, I mean, we say it's an urgency of this problem. We need to solve it, right?
Yeah.
So there is a moment that one technology is cannot deal with it anymore. We have this complex mixture. Then, okay, what to do? And put it back in our circular economy.
Yeah. How do you see us scaling this up? The word scaling chemical recycling up.
Yes, there is a huge collaboration with industries, with research centers, academia, and also governments in that direction. This is something that we need to develop. We need to develop as soon as possible, and we are playing an important role here.
Great. That really much sounds like partnerships, a lot of partnerships.
Yes.
And that's also something I want to talk about. After all, we are discussing SDG 17 partnerships for goals. And I mean, our main goal is to become more carbon neutral, to recycle more, to replace our unsustainable fuels. So what is, in some way right now, the business model of creating alternative fuels?
Yeah, in this case, once again, it's not, let's say, profit focus, right? It's sustainable focus. So we need to decarbonize this industry. We need to become more sustainable in that case. So that's the key point, and this is the target we are aiming at. So for that, of course, partnership between, as I mentioned, industry, research centers, and also governments and subsidy agencies are on that direction. We need to support these lines of research.
Okay, so in this case, we can talk about grants, subsidies, and then the private investors as well coming in. I believe that really the investments from private companies increased tenfold in the last few years when it comes to, let's say, biofuels, and when it actually comes to the research being so applicable that companies can start to invest in it, like KLM, for example, and start applying it as soon as possible because of the urgency of things. Okay, so we have already hinted a bit of examples, so we're going to talk a bit more about aviation and maritime fuels because they are very much in the business right now, and it shows a good collaboration opportunity. But what importance do these partnerships have for you, for the development of your research?
Yeah, I mean, these partnerships are critical. And also it's critical, let's say, from the starting point of view, right? When you apply for a subsidy or you, it's mandatory, let's say, to have this collaboration. But in my field, at the end, the only way to make an impact if my process gets applied to the society, right? Somehow. So if we upscale the process, and for that we need to go hand by hand with the industry. And in that case, we can upscale it, and then we can deliver the fuels or the chemicals to the society.
Yeah. Today, now you are on the research side, but you have also been on the other side. You have been in the inside, let's call it like that. You have worked for a company which was collaborating from the other side with researchers and also utilizing the talent to make their own business more profitable. So what challenges did they face, and how did they tackle those challenges?
Yes, that company was the core of that company was also renewable energy. So it was dealing in areas of bioenergy, hydrogen, also solar energy. So there I was working in the research center, in the central research part, right? So I was collaborating with the different business units. And of course, then you have different demands from the business units, and there is some urgency, right, to tackle some of the problems. And then this is how you define the research. But also I had the opportunity to define also my long-term lines of research, let's say, also to give it like as an input for the business units.
Okay. And how is the experience different working now at the UT compared to what you were doing at the company, and what kind of limits you may have?
Yeah, like in everything in life, there are pros and cons, right? So in the company, you have less freedom to define your research because, of course, there is a demand, there is a problem, there is a challenge that needs to be solved. And I would say here, of course, is the part of education, and you have more freedom to define the research. But also sometimes the good part also in the company is this urgency is more clear. So you see things advancing faster, I would say.
Okay. So how long would it take you to bring a research to the implementation phase at the university, and how long would that take at a company? Approximately.
Yeah. No, at the end, as I mentioned, is a collaboration, right? But then the first, it depends on the stage that we are talking. If you start from let's say very fundamental up to you get to a commercial plan, that could take 50 years. So that could take a long time.
Okay.
But if we are saying, okay, developments that you can make fast or decisions that you make fast to say, okay, after 1 year, the company could switch and say, okay, I'm not interested in this anymore because I'm now focusing on another part of the business. Then that's the urgency, that you move and take decisions really quick.
All right. Yeah, we heard how it's different, but something that is combining all of them, and it's relevant for all of them, is what is the future outlook for sustainable biofuels, and also later we'll talk about what's the future outlook for plastic recycling.
Yeah, so in the case of the biofuels, I think the future is on as I mentioned, in the aviation and maritime fuels. There is something when you are flying or remotely, you need to be supported by fuels, and then there is the way to go. And in the case of the plastic waste, of course, there is an urgency to close this cycle, to close this loop, and make it recyclable, and then avoid having waste in our seas and everywhere around. So these are the future lines, I would say. Yeah. And not only in the case of the biomass, I would not focus only on biofuels, but again, we can open to many biochemicals and biomaterials, which are already also some of them in place.
Yeah. And how do you see the UT and its research and your place in it developing, let's say, in the next 5-10 years?
Yes, I see our role like a really very important, and also we are very close to the application. So then you can see things happening and very fast. So that I think our role is quite important on helping developing this type of processes.
Great. Now I want to talk a bit about education as well and research. So could you tell us again which courses you were teaching?
Yeah, so regarding education, I'm teaching courses on sustainable chemicals, sustainable fuels, and also I'm teaching process simulation in the Master of Sustainable Energy Technology. Okay.
So what do you think students like about those courses? And do they actually realize the importance of the courses?
Yeah. So regarding the courses, I mean, of course, I think they appreciate the sustainable approach. See, like, of course, from the classic chemical engineering, you know many processes, right, on place, and then you can see, okay, what are the challenges of using different feedstocks? What are the opportunities we can create new chemicals, new intermediates that they can deliver new products? How to also to produce, I don't know, new materials like bioplastics, bio-based plastics. How to do that? So I think they appreciate this focus.
How do you try to challenge them? Do you have some projects with companies or within the UT trying to make them work together and figure out something?
Yeah, in these specific courses there is not a direct relation with the companies, but in other courses in the program of chemical engineering, indeed there is a close relation to companies tackling a problem and then trying to develop a process based on that.
Maybe something to look into the future.
Yeah.
Okay, now I want to hear a bit more about how do you feel about doing research at the UT? What is your experience? You have been here for some time now.
Yes.
How did you experience working at the UT, working with your colleagues, and just being a researcher at the UT?
Yeah, so what I can say is I'm really happy in the group that I am. I enjoy a lot working with the students, also educating students, master, bachelor, and PhD students. And the research that I'm doing is really like, fun. It's something I really, I like it. I like also the collaboration with all my colleagues, like trying to combine the different expertise. And also, specifically at UT and in my group, we have really very good facilities and also unique facilities like the high pressure lab, which allow us to make these studies also at different scales. Yeah. That is very important.
Yeah. We had our preparatory meeting in that side of Horst as well, where I've never been, and it does look very, very fancy, I must say. What was your most fun experience at the UT, if you can think of one? Or what's the most fun?
Yeah, I don't know. I think it's just group activities that is also, that is quite fun. Let's say. Yes.
Okay. Now back to something more serious. You said, okay, partnerships are super important. Otherwise, you cannot make an impact. How do you measure this impact that you try to make?
Yeah. So the impact, again, I measure by developing these processes, and then if eventually they are upscale or the improvement that I propose through my research is implemented in industry and eventually it comes to the society, then that's my impact because I made it happen, right?
Yeah.
And I collaborated for this. But also my impact is through my students. I educate future engineers, bachelor's, master, and also PhD students. And the impact that I can do for them later to work in this chemical engineering field, but also with this sustainable approach, that is the impact that I make.
Great. Do you know if any of your students actually went into, let's say, sustainable industry in general, or any industry in which they are now working in a sustainable role?
Yeah. I think most of them, they work through industry and also to help with this energy transition and becoming more sustainable. Yeah,
that's great. Yeah, that's the effect you want to see.
Yeah. This is what I want to see, and then amazing. I can see it. Yes.
Yeah. So I know it's a difficult question, but what would you want to leave as your legacy? I mean, we mentioned your impact, but if you look, for the next 10, 15 years, what do you want to leave behind?
Yeah, at the end, as a legacy, of course, is very important word, right? But at the end, my legacy is, again, the people that I train, right? And I work with. If at the end you can influence them positively, make an impact on how to approach problems from a sustainable way, how to do research in this way, I think that's the legacy that I will leave.
Okay. Inspirational. Inspirational. Now,
it's a difficult question.
Yeah, I know. Could you bring us some kind of takeaway message? And lastly, we can kind of get back to what SDG 17 is, so partnerships, and how does that relate it to our episode today?
So the take-home message for me is like a strong collaboration between academia, research centers, and industry, and of course the whole society in general, is key and is necessary to make the energy transition happen. And any step that we take in the opposite direction will slow down this transition and will make us fail in the fight against climate change. So that's critical.
That's critical. So yeah, we should, like another episode said as well, we should facilitate dialogue rather than keep everyone out.
Yes.
Look at the bigger picture.
Yes.
Look at the bigger
indeed.
picture. Amazing. Thank you very much for being here.
Thank you very much. It was really a pleasure.
For people that are interested in circular economy and recycling, more also about the implications of, let's say, industrial symbiosis, we'll have an episode with Devrim Yazan, so you can hear more about it. And also on the policy side of these, we'll have episodes as well. So thank you very much for being here, and thank you for the listeners as well. And see you soon.